A Whirlpool microwave that the light will not shut off. It says it's going half full and off, but it's not. The light stays on. And it's because there's a part of the circuit board that has failed. We're going to replace it. So I'm going to take the circuit board out and we're going to repair this circuit board. What often causes this is when the user unscrews a light bulb trying to replace it, this part of the light bulb twists off. When that happens, it causes the two wires that go into the light bulb filament to twist together. That shorts out the triac because it shorts out the circuit. It causes too much current to flow through the triac and causes the first and second lead of that triac to short out together. Whereas again, they're not supposed to be shorted together. They should be open with an ohm meter or a continuity meter. First, we're going to remove the grill. Remove the screw that holds the control panel on. Lift up the control panel. Take off the connectors. It's a good idea to take a picture of the back of the board before taking the connectors off so you know which way they go back on. Part that has gone bad is this triac right here. This triac is a semiconductor that is the equivalent of an AC relay, but at solid state. And it turns the light on, it dims it, and we've got two terminals here that are shorted. So this is how this triac turns on the light bulb. This is your light bulb right here. This is your hood light. That's the light bulb right there. So the current path is like this. You have the line voltage coming in right here. It goes through the fuse. It goes through a choke, which reduces noise and reduces the surge current when you plug in the microwave. Goes through the cavity thermostat, which should be a closed circuit. Comes through here this way through the triac. Now the triac is open, it's normally not on, it's not a closed circuit. And I'll show you how that triac gets turned on. It goes through here and meets up with one side of that light bulb. This is your load here, so this has resistance. So 120 volts is supposed to appear across that. The return path goes this way. It goes through another inductive choke that again reduces noise and reduces surge current when the microwave is plugged in, and returns through neutral. So that's your current path right there. And what happens, and the way this triac works is this is an electronic switch, and it is turned on by a biasing voltage right here. This biasing voltage here, just say, comes from a device like this. It's an opto-triac. You have an LED inside here that shines on another triac right here. We'll just call this a triac. Shines on that and it turns that triac on, and that triac sends a biasing voltage to this main triac right here. The reason we use this optocoupler is because a microcontroller is connected to this. All right, and you don't want, this is a microcontroller, you don't want this microcontroller to be in any way connected to the line voltage over here. So you have galvanic isolation by just having this microcontroller turning on an LED, and the LED just there's where your isolation is. It just shines on that triac. There, turns that mini triac on, and that turns on the main triac. And this is your opto isolator that contains the LED right there and contains the little mini triac that biases this triac right here. The other side of this is connected to the microcontroller, which is on the other side of this board here. So when the customer tries to replace a light bulb, what happens is the light bulb is really old. Then when you twist it, sometimes this threaded piece becomes separated from the glass, and those two wires there get twisted together. Well, that causes a dead short right here. And if that light is turned on when that happens, you've got current flowing. You have a lot of current flowing through here. And what happens, sometimes it'll trip the breaker because this fuse right here cannot react quick enough. It's a slow blow fuse. Or the fuse will blow, or nothing, or the breaker doesn't trip, or the fuse doesn't blow, because this sometimes is shorted out and so quickly and for such a short time. Neither that happens, but it shorts out this track. So this track becomes a wire, essentially becomes a wire, and that's what happens there. So the next time after you have that bulb replaced there, and you put a new bulb in, this track is already damaged. It's just a wire. It doesn't matter what this control circuit over here does anymore. In trying to control the triac, it can't control the triac anymore. And so that light bulb just stays on. That switch is basically closed all the time. So that's why you replace that triac right there. So that's how that circuit works. This is a replacement triac. This is a BT136, which is the exact triac that's in this board. I like replacing the parts with the exact part if possible. This is the reading on the triac on the board. It's reading 0 ohms, so we have a dead short. This is the reading on the new track. You should have infinite resistance. I'm going to go ahead and replace that triac with this new one, and it should work fine after that. This is where the back of the triac is in the board right here. So we're going to go ahead and remove that. This particular desoldering gun is the one I use, the Hako. You can use just about whatever type of desoldering method you want. There's our old triac right there. Okay, so we have the new triac in place with the leads appropriately bent. We'll go ahead and solder that in. Okay, we have the new triac soldered in. I'm going to go ahead and clip those leads and put the board back in. And we'll just reassemble this in the opposite order that we disassembled it. Okay, we've got the triac soldered in, got the board back in place, making sure that this ribbon cable is inserted all the way and that the screws were put in with very light torque so as not to damage the board. So we're going to go ahead and put the control panel back on and test this. Okay, we've got the board back in and the control panel back in. Okay, we've got the control panel back in. Let's go ahead and plug it in. And we'll go ahead and test it. I'm going to test the lights here. So we'll go ahead and press the light button. Okay, it's working, full brightness. This should be half brightness. There we go. Press it again, light goes off. So we have fixed the light control on the control board. That's it for this video. I hope you found it to be interesting and informative. If you'd like to join our Facebook group, here is a link to it right here, or you can go to Facebook groups and type in the keyword the tech circuit. This is a link to our website right here, and this is a link to our YouTube channel. Thanks for watching.